Thank you very much, Hans, Soren, and the others. Extremely interesting to see how the ecosystem works, and that's a word that you hear a lot when it comes to IoT, because the ecosystem is everything and it all feeds into everything else that's part of it, of course. And the other phrase you hear a lot is the industrial internet. There isn't a single industry in the world that can't take advantage of the Internet of Things. So next we have a presentation about the Internet of Things for industries and societies in transformation. So please welcome Sara Mazur. Sara is Vice President of Ericsson. She's also the company's Head of Research. Sara. Good morning.
Thank you. Good morning. Thank you for the introduction. Good morning, everyone. It's great to be here to talk to you about something that is of very high interest to me and in my world, and that is Internet of Things, 5G, and how those technologies can be used to transform industries and society. So we are not making cars, but we will help you do the awesome things with the cars through our technologies. First, I would like to say some words about Ericsson, because Ericsson is a company that has changed quite a lot during the recent years. So Ericsson is today active in 4 segments. The first segment, and perhaps the most well-known segment, is networks, where we are a world-leading vendor of networks, communication networks. Secondly, we work with IT, transforming the IT systems of mainly operators, but also other players through our technologies. Third, we're also very big in media and media transmission and media delivery. And last but not least, we're moving into industries and societies, working more with how our technologies can transform and add values to other industries and societies. Ericsson is also a company that invests a lot in R&D. So last year we actually invested 36 billion Swedish crowns. We have close to 26,000 employees working in R&D, and that has also made us have the world's strongest patent portfolio in our segment. We are a true global company, active in almost all of the countries in the world, and we today have close to 120,000 employees. Looking at on how Ericsson has changed, going back 15 years in time, the majority of what we sold from Ericsson was hardware, and around 35% was software and services. But that has changed a lot. So looking at the situation today, what we deliver to 66% is actually services and software, although hardware is still an important part of our business. And looking into R&D, we actually placed close to 90% of our investment in R&D in software today. So services and software are becoming increasingly important for the company. What is happening in the world around us is that we see more and more industries are using ICT technologies to transform. And we're all very well aware that some industries have already transformed, for instance, the music industry and the media industry, but more and more industries are looking into how can they benefit from introducing ICT technologies and, of course, also Internet of Things into their industries, making them more competitive for the future. How can these industries, by connecting, by adding the intelligence in the network, be more efficient, more resource efficient, modernize the business processes to meet the competition of the future? And this is something that is of key interest to us, and where we think that we can play an important role to help these companies. This you may have seen, the estimated value of Internet of Things. It's based on a McKinsey report. But what's important to notice is it's not actually the value of connecting things, it's the total value of how more efficient and competitive we can be in industries by transforming using both Internet of Things but also ICT technologies. And as you can see, the potential is huge. So there is so much to gain by introducing these technologies into industries, into societies, getting the upside of all of this, and it can actually add up to a tremendous amount of money in the future. Ericsson is today, as I said, moving more and more into industry segments, and today we are active mainly in 3 different segments. So we are active in energy and utilities, where we are working with smart grids, connected meters in several countries around the world. Transport and automotive is of course an area where we are active, working with how we can improve the transport and automotive industry or help you improve by using our technologies. And the third one is safety and security. And it's all, of course, targeting smarter cities, smarter industries, more added value. This is a recent example. It's a connected vineyard. It's not a car, but it's a vineyard. So what we have done here is that we have placed sensors measuring the temperature, the moisture in the soil, and it is connected through the network back to the winery to give them information on how is it working, when is it time to harvest, is everything okay, or do we need to do something? And the sensors are connected locally using a short-range radio technology, but to a gateway that then enables actually end-to-end security and encryption all the way out to the connected sensors by using the generic bootstrap architecture defined in 3GPP. So it's a very good solution for a vineyard. Looking into the number of connected devices, in our forecast now, we say that by 2020, we estimate that we will have 26 billion connected devices in the world. And the day before yesterday, we actually released our latest Ericsson Mobility Report. And there we even estimate that by 2021, we will have 150 million connected 5G devices with the newest technology. So this is extremely promising, and as you can see, in terms of what is growing, there is a very slow growth in mobile phones, fixed phones, so what is growing is actually consumer electronics, but the majority is machine to machine, or machine-type communication, as we call it. Maybe you're familiar of the Ericsson vision of the future that we call the network society. In the network society, we believe that every person, every business, every industry and society can reach the full potential by being connected to the network and share information and use the intelligence in the network. Ericsson Research, where I work, when we look at the network society from a technology perspective, we say that it's mainly built on 4 cornerstones. So the first cornerstone, those are all of the connected devices that we will see in the future, and we are starting to see more and more. So then we are not talking about phones, laptops, tablets. We are talking about cars, sensors, industry robots, consumer electronics, coffee machines. Anything that can benefit from being connected will be connected in the future. The second cornerstone are all of the applications that goes together with all of the connected devices. And as you may know, the majority of traffic in our networks today is, of course, communication, web browsing, but more than 50% is video today. But mainly video to consumers. When we're moving into the network society, we will have completely new application services running in our networks. So then we are moving just beyond communication, video, and web browsing into mission-critical services, business-critical services. If you have a service for an autonomous or self-driving car, of course that puts very different requirements that you have to support. Or if you're running remote surgery, or if you are connecting a big industry facility, posing completely new requirements on the network. Third cornerstone is the network, but then we are not talking about a network as of today. We are talking about a network with capabilities far beyond what we can support today. We're talking about a network that can, for every connected device and the associated service application, exactly make the network perform with the right performance for that requested device and service. So it's a very smart, service-aware, user-aware network that can adapt its performance to serve the needs from these different applications and connected devices. And fourth cornerstone is cloud. Partly because the majority of the applications already today are executing in the cloud, but also because we see cloud technologies coming into our networks. And in the future, the majority or maybe all of the functionality in the core of the network will be executing in a network-enabled cloud environment, a data center-like cloud environment in the network. And the reason that that is important for us is because we will have this cloud environment distributed in the network, which enables us to execute functionality on different places in the network, the same functionality at the same time, but for each specific service, giving exactly the right performance that is needed. We then also have four overarching areas. The first one is management, but in the future, not only management of networks, management maybe of cars, of fleets, of cities, public transportation, public safety. We have security. When everything is connected and all of the data is stored in the network and also in a cloud environment, of course we have to ensure that no one can breach into the networks, that no one can get access to data that they shouldn't have access to, and that we also can handle things as personal integrity and privacy in a good and ethical way. Sustainability. Partly sustainability of our networks, which mean very good energy performance, but also being able to connect small sensors with small batteries, giving them a much longer battery lifetime than today. But perhaps even more interesting, how our networks and our technologies can contribute to a sustainable growth of society and industries by making them more or enabling them to be more resource efficient. And of course, the service is related to that. And for us, mobility is key for the future. So how does this relate to 5G? This is the history of the generations of the mobile networks. And as you can see, it takes around 10 years between each generation. With 4G, I would say we have a very good mobile broadband system that most of us use here today. So what is then 5G? Well, 5G networks and 5G technologies, those are the networks and the technologies that we need to fully utilize the network society. We are on the way to the network society, so we are starting to see more and more things being connected. But to fully live up to my previous picture, we will need the 5G systems and the 5G technologies. And the journey to 5G has already started, but formally it will be available by 2020. So what can we expect from 5G? What is it? Well, of course, it's an even better mobile broadband system, which means that we will have higher data rates, we will have shorter latencies, we support higher volumes and so on, but it's much, much more. It's also a foundation for efficient industries and society. So this means that the use cases will cover things like smart vehicles, transport and infrastructure, media everywhere, and then also personalized media to every person, since that is the trend we see. Today, we pick the media that we want to consume. But also, we are moving much, much more into machine-type communication. So we will need to support both what we call massive machine-type communication, where we have very many sensors, but each one of them maybe not posing so high requirements on the network. And the critical type, critical machine type communication. And that is where we have the connected cars or the connected industries or the remote surgery or management of cities and so on. And looking on the two types of machine type communication, they are actually very different. If we look at the massive type, the requirements that we have to meet there are that we have to be cheap, low cost, very low energy consumption to allow a small sensor with a small battery to live for a long time. We need to have very good coverage, very long range, support huge number of connected devices, but small data volumes for each device. Whereas the critical type is completely different. Here we are talking about extremely short latencies, extremely high availability, and an ultra-reliable network. So machine type communication for us is not one thing, it's at least two very different things that we need to support. So looking at the requirements for 5G, these are the requirements that have been agreed in the European project METIS that was led and driven by Ericsson, but where we had partners from, well, 27 partners, so basically everyone participated. So with 5G, we need to support 1,000 times the data volumes we have today. With a device density, number of devices per area, up to 100 times higher than we have today. We need to support latencies down to 5 times shorter what we have today, and that is down to around 1 millisecond latency in the network. Up to 100 times the user data rates that we have today. That is ranging then to 10 or 20 gigabits per second. And also we shall be able to connect the small sensors, giving them a 10 times longer battery lifetime than if we were to connect them with today's technologies. To meet all of these requirements, we have to involve the entire network. So of course we are working a lot with evolving the radio and the radio access, but that will not give everything. We also have to work with the IP infrastructure, with the cloud infrastructure in the network, with the network features or network functionalities called network applications here that will be virtualized in this time frame. We need to work with management and orchestration, and also sustainability and security. And we also need to have a very good understanding of the types of devices that we are going to connect and the applications that we need to support for those devices. So that is what we're working on now, up to 2020. The way we are planning to realize this, that we're saying we will have one physical network that will support all of these connected devices and the services. But in this same physical network, we are realizing something that we call network slicing. And what we in reality are doing is that for each connected device connecting to its cloud service, we are realizing a virtual network, a software-defined network, making the connected device and the application act as if they had a network on their own. So each of them will perceive the network as their own network, but it is a virtual software-defined slice in the same physical network. So that is how the 5G networks will support all of these different services and connected devices for the future. What is good, though, is that we don't have to wait until 2020 to do this, because a lot of this evolution is already ongoing, and that is also true for the radio access. So 5G will, to a very large extent, in existing spectrum, be based on the evolution of 4G. And then we will complement with new technologies, mainly in higher frequencies. So our ambition is to evolve 4G as far as we can to meet the 5G requirements. And this work is already ongoing. So as we speak, we are enhancing 4G with better features, of course, for mobile broadband, but specifically also to meet the requirements from massive machine type communication and critical machine type communication. So there's no need to wait until 2020. We can start already now, and what we are building on now will continuously evolve until 2020 to meet the full 5G requirements. For us to get an even better understanding of the industries that will transform using the 5G networks, we have launched an initiative that we call 5G for Sweden, and also another one that we call 5G for Europe. And 5G for Sweden was launched earlier this year. What we're doing in 5G for Sweden is that we are cooperating with industries in Sweden with the objective to increase competitiveness of Swedish industries in a 5G timeframe. And there are several reasons for us to start these cooperation projects. The first one is for us to learn. If we are now designing, building the systems that will start operating by 2020, but then continue maybe for 10 or 15 years after that, supporting industries, we need to understand the requirements that we have to support. That is one reason to join into this cooperation. The other reason is for the industries that work with us to understand what the 5G technologies can do for their industries. And last but not least, innovation. When we meet across industries, a lot of innovation spontaneously occurs. So we have quite a lot of partners in 5G for Sweden. We are working with Scania and KTH in the Integrated Transport Research Lab at KTH. We are working in something that's called PIM, Connecting a Mind, together with ABB, Boliden, Luleå Tekniska Universitet, SIX, Volvo, Wolfit, and I hope I got them all right. And those are just two examples. There are more projects that have started and more will come as we go on. And it's extremely interesting for us. So what is IoT in all of this then? Well, our view is that IoT, Internet of Things, is a digital representation of the real world. So anything that we want to interact with, to monitor, to measure or to control, will have a digital representation in the IoT world. And it can be things like measuring the properties of a sensor, can be heartbeat, temperature, fuel consumption, but also we want to be able to control, to have the actuators to actually steer and control what is happening in the IoT world, in this digital representation of the world. So also bringing in things like maybe we want to turn things on and off, increase or decrease, steer things. So it's both the measuring part, collecting the data, but also after analyzing, going back and doing the actuation in the IoT devices. Some typical use cases that we are working on IoT are, for instance, massive monitoring, asset management and tracking. And then we have the more critical cases, such as remote operation and robots, and also infrastructure monitor and control. 4 typical use cases. Key technical components for IoT are, of course, the device, the connected device, the network that I already talked a lot about, but also the intelligent software, the intelligence and semantics that really is the key enabler of creating this value, where we have the analytics, we have the knowledge management, and we have things like automation. So looking a bit more into the intelligent software in the network, we will collect data from events, from the sensors, from the connected devices, process the data using analytics technology, introduce things like machine learning, but also interact with knowledge bases, working on knowledge management and decision support, control logic, introducing automation technologies, and then come back to actionable services that we then will actuate in the connected devices. Looking at the device or device technology, there are several trends. Of course, we are looking into higher capacity, higher processing capacity, multi-core, higher clock speeds, but perhaps even more important is to look in how can we get these smaller, cheaper, with a smaller footprint. And there we have technologies such as MEMS, where we think that we can reduce cost and size with a factor of 3 in the coming 3 years. To make really IoT go mainstream, there are a few things that we think are really important. The first one is that we need to go IP, and that is on track. That is happening. We need to use web and web technologies, and that is in progress. We see more and more web technologies coming into the IoT world. But the last one is really important. Go simple. Today, in our view, the IoT world is too fragmented. There are too many solutions, too many specific tools. We need to do this in a simpler, more mainstream way to get the full leverage out of IoT. So go simple. Use standard technologies, use standard tools to get the leverage from the big ecosystem. Someone mentioned the ecosystem here. The ecosystem is important. The size of the ecosystem is really important. So to summarize, we see that ICT is rapidly transforming both industries and societies, and we have the ambition to be a key player in that transformation. A key component for this transformation is the Internet of Things, and it has an enormous potential in the transformation of industries and societies. We are engaging with other players from Ericsson. We are both business-wise but also research-wise to work more with new industries and more with society. Both for us to learn, but also for others to learn from us, and also to spur innovation. And before I close, I just want to say that we have a few demos over there, over in the Ericsson booth, that if you want to know more about what we're doing, you're welcome to come and visit us. We have the automated network transport demo, and we also have a demo on cloud for industrial applications, as well as our cloud platform, and I think 1 or 2 more. So most welcome, come and visit the Ericsson booth. Thank you very much.
Sara, thank you very much indeed. Really fantastic.
Thank you.
So you get an idea of if you want to take your seat, then we'll hear from one more presentation before